Hi, welcome to Project Geospatial. I'm Adam Simmons here at GEOINT 2022 here in Denver, Colorado. I have the honor of speaking with Nathan Kundtz, CEO of Rendered.AI. And how about you tell us a little bit about yourself and we'll dive right into the company.
Sure, yeah, so in terms of background, I'm a physicist by training, entrepreneur by birth defect. My first company was in the satellite communications space, built that and delivered product and service globally before handing that off to a management team, and then founded Rendered.AI, where we're really excited to start probing that interface between what we can simulate and understand through physics-based simulation, and increasingly what we were able to understand through building artificial intelligence algorithms.
Well, tell us a little bit more about what that means when you're diving into creating simulated data.
Yeah, so it turns out for a lot of different applications in artificial intelligence, there's this fundamental problem of lack of access to data, and that's for a lot of different reasons. So sometimes it's rare events and edge cases where we just don't see enough of the things that are really important to find. GeoINT's a great example of a domain in which that's crucial, obviously. Or it can be annotation issues. It turns out it's really hard to get human beings to label data effectively. Even with things where you might expect someone to be able to recognize what's in it, it can be difficult. But as you get into other imaging modalities, LiDAR, synthetic aperture radar, infrared, it becomes almost impossible for humans to label. And so that ends up creating noise in those systems, or just makes it impossible to build AI algorithms. And then finally, and I think it's really relevant for this community, if you're building up a next generation sensor or capability these days, it's really hard to connect sensor specifications to the insights that sensor is going to be able to generate. So unless you can generate simulations, not just of the sensor, but really of data at scale, and connect that into the insights that can be gleaned from the deployment of that sensor, it's hard to build a business model. It's hard to justify, what it is you're really trying to accomplish with that. And so a way to address those needs is to use what's called synthetic data, so producing large data sets and diverse data sets that are simulated based on the domain in question. And so we provide a whole series of tools to make that effective and help make our customers successful with synthetic data.
Excellent. Now, there's a lot of stereotypes around synthetic data not being able to, not being enough or not being good enough to contribute to the machine learning problem. Can you talk a little bit about your success stories and why that's just totally not the case?
Yeah, we've had a lot of success with synthetic data, and both in terms of augmenting real data to achieve higher performance in AI, but as well in zero-shot learning, where we only have access to synthetic data and still getting relatively high performance. I think the reason that some folks have not had as much success as maybe they could have is if you don't really think about the challenges involved in producing synthetic data, it can be easy to oversimplify the problem. So if you say, hey, I'm just going to simulate something, okay, but you end up simulating a lot of the same thing, you end up overfitting, you end up getting really good at detecting the things that are in your simulations as opposed to things that are in the real world. To do synthetic data effectively, it's a pretty prolonged process where you have to have a sizable asset integration capability, so 3D models, backgrounds, things like that. Procedural generation becomes really important. The simulation tools are critical, so picking the right ones, right? Not necessarily video game engines, but maybe higher fidelity simulation tools. There's a compute orchestration problem if you're going to do large volumes of simulation at scale. Data set aggregation, librarianship, data provenance of that so that you can continue to do experiments. There's things like domain adaptation become really important, and then of course quality assessment. And if you don't do all of those steps, you get a really bad result. In fact, if you don't do all those steps relatively well, it's really easy to end up with a bad result. And so our experience is that when those are implemented properly, and then engineers are enabled to really work the problem, you get to really effective uses of synthetic data.
Excellent. Going back a few steps here, what kinds of, we loosely talked about imagery. You loosely talked about modalities.
Yep.
Can you talk about the wide spectrum of modalities and types of imagery that you've been able to generate?
Sure. So we've worked across quite a few domains. So of course, kind of RGB imagery is sort of a starter point. There's a lot of different rendering engines to choose from there. But we've worked in synthetic aperture radar. We've worked in infrared, both terrestrially and spaceborne. We're starting to work in hyperspectral imagery with a partnership with Deersig that we're very excited about. In fact, we've done some microscopy simulation as well, so we've really walked across a wide variety of domains. And the reason that we can do that is what we've done with our tooling is we've looked at all those steps that I highlighted and really started to break down, the tools that are important across really any of these simulation and synthetic data environments, as opposed to the things that are part of a particular problem set. We've separated those out effectively, and that allows us to get a lot of leverage from the tool set for each of these new problem areas.
Excellent. Well, you mentioned Deersig just a second ago. That's fairly new, right? That partnership?
Yeah, we just announced that last week. We're very excited about the partnership with Deersig. So Deersig is really the provider of some of the best simulation software across hyperspectral and multispectral simulation capabilities. They've got 30 years of experience coming out of RIT, not only building up the simulation software, but also then comparing that and contrasting it with real-world data collection. So phenomenally sophisticated tools. And where we come in is really turning that into something that can be done at scale, that is integrated with data set management, 3D model library acquisition, and then we have a whole environment that is tailored to the needs of the data scientist. So if you think about a tool like Deersig, it's very much focused on a simulation user. So somebody who typically knows something about those sensors. You kind of have to be able to drive the tool. And so we come in, bring that to scale, and then also provide an interface that makes that relevant to a data scientist.
So going back a second on your what's the level of, you kind of touched on how difficult it is and the nuances of where in machine learning, how important it is to do this right. What's the workflow of generating a model of a new object or new area to simulate something for your customers? What's the level of effort? What's the workflow look like when you receive a request like that?
Yeah, boy. It's obviously that's a very deep question that has a lot of moving parts in it. We usually start by just really trying to understand a combination of, what are you trying to look at and what are you trying to look at it with? And what environment are you in?
And maybe even why.
And why? Yeah, actually, that becomes very important. So let me say this. So I highlighted a few of the steps. So there's 3D model acquisition. There's procedural generation. There's simulation techniques. Those are all really crucial and tend to be more problem specific. And so we have a developer environment that allows us to actually build up some of those capabilities in a way that we can tailor them to particular problem sets. And that's been very powerful for us. But understanding the why and what people are really after becomes crucial. And I think this is sort of latent in that it all needs to be extensible. It turns out that this is not the kind of problem where you just sort of build the solution for a sensor and you're done. There's always something new to find. There's always some new artifact. It turns out artificial intelligence is not the first form of software that doesn't have bugs. and for artificial intelligence, what it means to fix bugs is it means introducing new data. And so all of those capabilities need to be built on and extended upon. For the companies that are successful, it's a massive differentiator and it's a corporate capability they continue to invest in.
Excellent. This is your first big year at the GEOINT Symposium, right?
Yeah.
And tell us what being here means and what you hope to accomplish at an event like this.
Sure. Well, boy, it's exciting to be here, in person, 3D. Yeah. Wow.
3D.
Yeah, exactly.
He's not a simulation.
I'm not a simulation. I'm actually here, not synthetic. Look, for me, this is my first GEOINT ever, personally. This is the first time we've had a booth anywhere. We're excited to be here, and just the community here seems very tech forward, very welcoming. We think there's generally a lot of interest and need for synthetic data across the industry, and a lot of different ways in which companies participate. So there's simulation providers here. There are folks that specialize in analytics. There are folks that really specialize in providing sensors and sensor data. And synthetic data touches on all of those. So this is a perfect place for us to be and really discuss what synthetic data means to each of those communities.
Great. So I'm going to leave you with this. I want a big question. I'll let you have a chance to finish off with any other announcements and things like that. Sure. But one of the questions I have is, what is one major obstacle that the community still has to overcome with not necessarily just simulated data, but in terms of machine learning or perhaps machine learning ops that might involve simulated data?
Yeah, far be it from me to sort of provide any kind of criticism to the community, but if you look at AI in general, there's a challenge in that it is a very linear workflow. You kind of have a data set, you build what you can upon it, and then that's the performance that you get. And it's very hard to iterate, it's very hard to fix bugs, it's very hard to achieve higher performance if you haven't already gotten where you need to be. And so I think that taking AI into the world of maybe what I might call proper systems engineering is something that I'd like to see, where we can begin to quantify the edges of performance and then improve upon them where they need to be improved upon. If you look at other types of engineering, you don't build a bridge and say it's going to carry everything. You build a bridge and say it's carrying this much. That's what we've designed it for. And we need to get to the same place with AI, where we can sort of test those boundaries and say it's meant to perform within this domain, and we're not there yet. And so I see a lot of what still is sort of, it works until it doesn't, which could happen at any particular point. And so, growing past that will be important. Now, in terms of some of the other things that we've got going on, we're also announcing a partnership with Esri that we're really, really excited about. So we mentioned the simulation side, but the other is, how do you get that sort of immersive world environment that allows you to start simulating things in the first place? And so what we've done is we built a partnership with Esri that allows us to ingest their data layers into synthetic data environments. So we can sort of produce both 2D and 3D background information. We can ingest building information. We can ingest, they have thousands of different layers of GIS data, and all of those are potentially relevant for things that folks might want to simulate. So we're really excited about that partnership as well.
That's awesome. So actually, big distribution there, and putting put the hands of simulated data in the hands of a bigger user base too.
Absolutely. So, Esri has some 300,000 different user organizations on ArcGIS, and we think many of them will find relevance in synthetic data, right? Whether that's for data modeling, sort of extensible digital twin capabilities, or artificial intelligence. And we're excited to bring them some new tools.
So you hint at something here.
Sure.
Is there any... do you have plans to make perhaps even an entire simulated globe, or any potential connections to, I think an underlying emerging theme here is I keep on hearing is the Metaverse.
Yep.
Are you involved in any of that?
Well, we're definitely involved in that. In fact, we just at GTC announced our partnership with NVIDIA and integration of Omniverse capabilities into the platform. But I'll say this, there's a lot of folks building 3D environments and digital twins. And what we see a lot less of is the infrastructure necessary to make those powerful, to solve real business problems. And so, we've been focusing our attention on the tools necessary to take those capabilities and turn them into insights and sort of meaningful business potential. I think that's where we'll continue to make our investments.
Awesome. Well, Nathan, I appreciate your time here at Project Geospatial, giving us a rundown of Rendered.AI. I'm Adam Simmons with Project Geospatial, and we'll talk to everybody next time.
Thanks, Ed.